Welcome to the Austrian Smart System Integration Research Center in Carinthia. We have worked with 14 industrial partners and 11 scientific partners over the past 4 years in 17 innovative projects. We are very happy that the number of researchers in the past 4 years doubled. And out of these researchers, nearly 20% are female researchers. And 23 PhDs have been finalized in the COMET Center. We have many exciting results that we would like to share with you.
During the last 4 years, we could extend our cooperation with many new scientific partners and industrial partners, and we could extend our expertise in some new directions. We developed the competencies in direction of the telecommunications, sensing and actuations, mainly in relation with the MEMS and microfabrication technologies. The importance of the program such as ASSIC is to bring different competencies and disciplines in one center. So it means to having a full view of product development and prototype development gives us also a better understanding of the full system.
The project focuses on computational magnetism in magnetic position systems, with specific focus on industrial and automotive systems. The biggest contribution from our side is the utilization of analytical models for permanent magnets and to use these models in high-dimensional optimization problems to optimize system layout, system geometry. And by system, I mean magnet and sensor.
One of the highlights of the ASSIC program was the work that we have done to develop MEMS micromirrors based on the piezoelectric materials.
We are developing small micromirrors for laser projection and distance measurement. These are designed, manufactured, characterized and integrated to the full system by our expert in our 300 meter square microfabrication clean room.
We are very happy because what we have developed in this program will go beyond ASSIC and will be also in the next years developed further.
In the heterogeneous integration and packaging area, we deal basically with the chip, with the sensor or the device, which is already finalized, and we bring it to the next step of the system integration. So one area is this wafer level packaging. Another aspect that we had a look at is the multi-domain simulation. So you can imagine that when it comes to miniaturization, all the physical domains become interrelated. Here it's very important also on the packaging level to understand the phenomena, for instance, to avoid die cracking or unintended die stress that impedes your sensor signal.
Within the context of wafer level packaging in ASSIC, we had several projects in which wafer bonding and innovation in the process of wafer bonding was the focus. In this project, we proposed a fabrication process for NMR gyroscopes in which the costly xenon isotopes are being utilized by developing a customized bond chuck and an external gas controlling system that was connected to the bonder with the software. And we significantly reduced the consumption of the gas through this process, which could be of benefit of the further upscaling of these gyroscopes for autonomous driving.
I think one of the great advantages of ASSIC is really the flexibility that you have inside this program next to its long-term perspective of 4 years. So within ASSIC we were able to change also approaches, technical approaches, when we find it useful, and this is much easier to implement compared to other programs.
Within our area, we basically implement sensing systems in completely different fields that ranges from sorting to applications in automotive to nutrition management, for example, where we try to measure nutrients in food online directly in the device used in the kitchen.
In the project SmartSense 2, we were working together with the industry partner Philips Domestic Appliances on the development of sensors for next-generation kitchen appliances. One project goal was the development of a compact ATR sugar sensor that can be implemented in juicers or blenders to monitor the sugar content of the prepared juices and smoothies. Based on the sensor's measurements, recommendations can be given to ensure the user's preferred sugar levels or to assist users that need to monitor their sugar intake because of dietary needs or health issues. This is an important step towards personalized nutrition.
Three-dimensional laser scanning is instrumental to many applications such as optical sensing, biomedical imaging and laser microprocessing. While lateral scanning can easily achieve resolutions of several hundred points and speed of several tens of kilohertz, axial scanning has so far represented a bottleneck in both resolution and speed. In the scope of ASSIC, we have been focusing on pushing the boundaries of what was so far possible. Thanks to excellent state-of-the-art microfabrication technology, we have developed a novel piezoelectric varifocal mirror, achieving a total power of 100 diopters and operation beyond 400 kHz, setting a new record in both speed and optical power.
The key element of COMET is cooperation. Cooperation along the value chain. We would like to thank our industrial and scientific partners for their trust all these years and for their great work together. We are very happy with all that we achieved together, and we are looking forward to continuing our cooperation on interesting and exciting new topics. We would like also to thank our funding bodies. Last but not least, a great thank you goes to all our researchers involved in the ASSIC projects. Without your excellent research work and enthusiasm, all of ASSIC would not have been possible. Only together we can unfold the future.